The black smut will grow. The only problem with it is it's not adherent. So actually, if you got your finger, you could write your name in the thing. You actually break the crystalline structure, break it down. So but you need to remove it to get it back to that nice aluminium that you're going to actually electroplate to. So it's called desmutting. So anything really, you want anything that will remove copper oxide and make it soluble. Usually it's an acid, okay? And in days gone by, and still some people use it, nitric acid was used. Copper oxide will dissolve in nitric acid very, very quickly, very, very readily, forms copper nitrate, which is blue. There's the reaction, and the byproduct is water. The problem with nitric acid is nowadays it's not classed as a very health and safety product because of NOx fumes. You can get brown fumes of NO2, which obviously are not good. Okay. So alternatives now, instead of nitric acid, are these mixtures, which is things like sodium persulfate, potassium persulfate, and a sulfuric acid mix. That is an etch for copper, and it will dissolve the copper oxide very, very quickly. Okay? And you end up with a solution of copper sulfate, which is very easy to dispose of. It becomes copper sulfate and sulfuric acid, which is basically a copper sulfate plating solution. So you can win the copper back by electroplating it as a disposal method of the copper. And I have seen tanks where they use this system, maintain peroxide, the sulfate and the sulfuric levels, but also plate it out at the same time. So you've got a continuous cycle. You give it up, you win it back. Silicon, again, this was mentioned. Silicon is often added. It has a low density, low solubility, and precipitates within it as almost pure silicon, which being hard improves abrasion resistance and is found in castings and things like that. But it has one problem. When you etch it with caustic, the silica doesn't etch. It just stands there. And actually, if you etch it deep enough, you can actually, and you rub your finger over the top very lightly, you'll feel the roughness of the silicon particles on the surface. Okay? And again. So the caustic will tend to react with all the aluminium and any aluminium parts around it and leave this microfilm of dust on the surface, which is silica. You can actually plate on it, but it won't be very smooth. And again. If we imagine, and I mean this is just a John schematic, and it isn't a very good one at that, but this is your piece of aluminium, like that piece you've been looking at there, okay? And then we etch this, and one more. Right, these little dots, if you can imagine, that's your silicon dispersed amongst the aluminium. So, one more. When you etch it, you can see at the top there, this is the silicon layer that's being left on the top that you've got to remove. Okay, so this is the alloy, and obviously after etching you're left with this dust of silica on the top. And that's an example of a microsection of what it looks like after it's been etched in a caustic etch. These large lumps here are the silica. This underneath is the actual aluminium etched coating. That has been slightly exaggerated, obviously for the purpose of showing you the photograph, but in real terms, that's what it looks like. And if you don't do anything about it, these lumps here will just get magnified up in electroplating. So we've got to remove that silicon smut, okay? So you need something that will dissolve silicon, and that product is a fluoride-based solvent, such as fluoboric acid, Eden fluoride itself, what's called a dry acid salt. Anything that will produce a fluoride will dissolve the silicon and then produce a byproduct called a silica fluoride. So you can use HF, not the nicest of things to use, or you can use dry acid salts. So you can use it as a mixture. You come out after you're etching, and you go in a mixture of nitric acid, a ratio of 1:3, and that will then remove the silica off the surface and leave you with an etched aluminium, clean etched aluminium surface, which, bear in mind, as Jan said, immediately you rinse it, will form an oxide layer again. There is an alternative etch nowadays that people can use, which is based on a mixed fluoride rather than a caustic. Okay? So you get this differential attack because you've got different metals there. With caustic, as I said before, aluminium will always preferentially get attacked. Copper wouldn't get attacked. Iron, even below it, would get a degree, but not to the same extent. But if you use an etching system based on a fluoride, you tend to get attack of all the metals that are actually in the alloy, which is better, actually. You don't get any smut. It dissolves the smut straight away, and you're left with a very, very, very clean etch. If you pass that one around, that actually has been etched for 4 minutes in one of these fluoride etches, and that surface is then good enough to electroplate on to get you a good bond. Okay? Again, go back again, after you've etched it, you must rinse it, make sure that there's no water breaks on the surface, and then you move on to the next step. Yes, very important. Now the next step is applying a zinc coating to it called zincate solution. And the application of this zinc allows you to remove it from the solution, expose it to the air, and not pick up any further oxygen. So effectively what you're looking at now is plating on zinc rather than plating on aluminium oxide. Okay? So the zincate solution applies the zinc coating by immersion onto the aluminium coating component, and is then sufficient to prevent the reoxidation of aluminium and allow the subsequent metal to be plated with good adhesion. It's primarily sodium hydroxide and zinc oxide dissolved together to form a thing called sodium zincate. Often other metals are added, such as iron and whatnot. That tends to control the uniformity of the zincate over the surface of the aluminium. Most zincate process, you can do it once. You can take your aluminium, you etch it, you swill it, you rinse it, you put it into your zincate process, you leave it for about 1 minute, you take it out, you rinse it. You can plate that, and you can get good adhesion. But if you go to a double zincate process where you zincate it, you strip the zincate back off again, and then you go and zincate it again, but half the time of what you did in the first one, your adhesion almost doubles. So a double zincate process is very, very important. So you get the sequence of zincate, usually 1 minute immersion, that's your first one. A rinse, strip the zincate, usually again in nitric acid, a rinse, and then you zinc it again. This time between about 30 and 45 seconds. And what you should end up with is, you can take these out by all means, don't worry about handling them if you want to, but you can see now that there is now a grey coating of zinc on that particular piece of aluminium. And that is what we're now going to plate onto. So effectively we're plating onto a zinc coated aluminium. Rinse again. You must make sure that there's no grease or anything, otherwise you can get bad adhesion. So then we electroplate the zinc coating. Now the problem with electroplating the zinc coating is you can't just dip it in any chemistry. Bear in mind zinc can dissolve in acids very easily. It can also dissolve in high alkalis. So you want something that's got a pH of around 4, say to about 8. If it's below 4, what happens is you put the part in, and before you've even made connection, it's dissolved off. And immediately it's dissolved off, you're back to aluminium oxide, you try and plate on that, it won't stick. So you're looking for somewhere about 4 to 6, which are what electroplated nickel is. It has a pH of about 4.5. You can put it in, make your connection, absolutely superb. It won't dissolve off. Small amount will, but not enough to cause you a problem. So again, the pH normally of a Watts is somewhere between 4.2 and 4.8. They can run as low as 3.5, but if you were plating aluminium, I certainly would not recommend 3.5 because you could strip that coating off. So as I say, you can't go in things like acid copper because it will plate, but it won't stick. The zinc will be removed too quickly and adhesion failure will occur. And then you plate it up to whatever thickness you want to plate it up to. Okay. You can use cyanide copper. Cyanide copper can be used providing the pH is not too high, and you certainly don't want it much above 9. Now, high-speed cyanide coppers can be very high. They can be up to about 14. They will not do at all. You'll have the same problem as if it's high acidic. You put the part in, you'll strip the zinc case off, you get bad adhesion. Cyanide coppers are a little more tricky to use than nickels, and to be very honest with you, I would say 99% of the people up and down the country will always use a good Watts nickel. So there are you don't get something for nothing in the world, and there is a drawback. Immediately you put the zinc in, even though you make electrical connection, and it's always a good idea to just put a little bit of voltage on the electrolytic nickel so that when it goes in, it starts to plate. Zinc will slowly dissolve into the electrolyte. Okay? And that zinc content will tend to rise in the electrolyte. And if it becomes too high, you will co-deposit a black coating of nickel and zinc at low current densities. You're usually looking for somewhere between 8 and 10 parts per million for this to happen. And if it does start to happen, you then have to just treat it, get rid of the zinc out of the bath with low current density. But often, and I mean there's a company not too far from here who plates that 100% aluminium in a nickel bath. They never had to do a plating out because the design of the jobs that they do, it's plating out all the time, but it's in such low concentrations you never see it. So they don't have to have a problem with it. You can also use electroless nickel as well as electrolytic nickel. Again, electroless nickel is a pH of around 4.5, 4.8, that sort of number, which is ideal. You put the part in, and immediately you put the part in, it starts plating. You can see it, it just goes for it. You do get a small amount of zinc dissolve, but not enough. Even if all the zinc dissolves and it's plating, because you're in a reducing atmosphere in electroless nickel, there's a big hydrogen layer coming off, the aluminium won't oxide. It won't oxidize up. You plate on the aluminium, it will stick. The trouble is you get, again, as in electrolytic nickels, you will get a small amount of zinc dissolving into the solution. This then becomes a drawback in electroless nickel, because what happens is you can't remove the zinc out of the electroless nickel, and it tends to slow the plating rate down. And if you keep going and going, it will actually poison the bath and kill it off. Now, what platers do, I don't know whether you're familiar with electroless nickel, but most electroless nickels are about 6 grams per litre of nickel. So if you've got 6 grams in 1 litre and you use 6 grams up plating parts and keep replenishing it, they call that 1 metal turnover. So most electroless nickels will do 6, so you can consume 36 grams of nickel. If you use aluminium and you plate it on aluminium, right, you can go to around about 3 metal turnovers. So you can turn that metal over 3 times, use 6 grams, use 6 grams, use 6 grams. And what happens then, the plater, if they're doing steel parts as well, will then stop using that particular bath for aluminium. They'll use it for steel and carry on till it's exhausted and start up a new bath purely for aluminium. So you get the maximum out of electroless nickel. Bear in mind that electroless nickel is about 10 times the cost of ordinary nickel to plate. So you want to get your value for money at the end of the day. Okay, so if we flick through these one by one, so this basically is what we've talked about. So degrease, remove grease to the walls, rinse, etch, provide a key, rinse, remove the excesses, de-smut if there's any copper or silica, rinse, zincate it, rinse, strip the zincate, zincate it, rinse it again, zincate it again, and then electroplate. So that basically is the standard process used for aluminium, plating aluminium. And it's been like that since time immemorial. Nobody's produced another way of doing it. It works extremely well. It's very simple. It's, if you do it right, you can get 100% success out of it, and you get some very good plating results out of it. And it does really have some high strength adhesion, especially by doing the double zincate process here. Okay? So this is what you've seen. This is, I know it doesn't look like a polished bit of aluminium. It's very difficult to photograph a polished bit of aluminium because all you do is see your face in it. But basically these are the polishing marks on it. Next one is the etched aluminium, which you can see it's just a uniform etched part on it. If that was etched in, and that was etched in acid, if it was etched in caustic, it would be a coarser finish on that. You would get a coarser etch on the surface. And then the next one is the zincated one, which is always this sort of greyish colour. The other thing as well, if you ever do electroplating and you're into electroplating aluminium, you don't want this colour to be too dark. If it is too dark, there's too much zinc on it, and you can get an adhesion problem. So it really wants to be like the part that's been going around. It's just there. Okay? Right, that's it. I've taught you how to plate up aluminium. You all know about it. Any questions?